variable optimization along with the equality constraints, right? So first thing, what is new here? There are more than one equality constraint, right? So this is one thing, and the second thing is that to determine the optimize the value of fx, that is the given objective function, is maximum or minimum. So till now what we were given, no, in example only we were given maximize the objective function, minimize the objective function with this equality constraint. But here I've taken a problem in which they haven't given us anything. They have told us to optimize this NLP, and they have given us the two constraints, and they have told us, or they have asked us to say whether the optimized value of z is a minimum value or a maximum value, right? So no, the question is solve the non-linear programming problem. Optimize z is equal to 4x1 square plus 2x2 square plus x3 square minus 4x1 x2 subject to constraints x1 plus x2 plus x3 is equal to 15. Then we have twice of x1 minus x2 plus twice of x3 is equal to 20. Then we have x1 comma x2 comma x3 greater than or equal to 0. So this is the numerical. Also find the optimized value of fx is maximum or minimum. Right, so this is the numerical that they have given. Now what we are going to do is we are going to start with very simple funda. Yesterday's only method, only the last part or the later part is going to change. Otherwise, all is going to remain the same only. All right. So what we have here is we have f of x, which is 4x1 square plus twice x2 square plus x3 square minus 4x1 x2. So we are having this. Then we are having the constraint which can be written as g1x, right? So which is x1 plus x2 plus x3 minus 15 is equal to 0. So this is the equation that we have. We also have g2x, which is twice of x1 minus x2 plus twice of x3 minus 20 is equal to 0, right? So yesterday we have seen this particular g1x, g2x are nothing but the constraint. Now what we are going to do is we are going to frame out the Lagrangian function. Lagrangian function, right? So it is given as f of x1 comma x2 comma x3. Yesterday we have seen we had only one constraint, so we had used only one Lagrangian function, that is lambda 1. But now here there are how many? There are two constraints. So what we are going to do, we are going to use two Lagrangian functions, that Lagrangian constant, that is lambda 1 and lambda 2, right? So what we can write with yesterday's knowledge is that it is 4x1 square plus twice of x2 square plus x3 square minus 4x1 x2 minus lambda 1 x1 plus x2 plus x3 minus 15 minus lambda 2, which is twice of x1 minus x2 plus twice of x3 minus 20. Right? So I'm hoping that you have understood this. So this is the nothing but this is the Lagrangian function, which is the function of your x1, x2, x3, lambda 1 and lambda 2. Right? So I'm hoping that you have understood this. Right? So what we can do next is now. Now yesterday we had seen when we have a single constraint. So the necessary conditions yesterday were what? Necessary conditions or the conditions that we particularly followed were what? It was dabba L upon dabba x1 must be equal to 0, right? Then we have seen dabba L upon dabba x2 should be equal to 0. Also dabba L upon dabba x3 is equal to 0, right? Again, yesterday with respect to this, what we have seen, we yesterday this condition we have written, right? So dabba L upon dabba lambda is equal to 0, but now here we have two lambdas, right? So here it will be dabba L upon dabba lambda 1 is equal to 0 and dabba L upon dabba lambda 2 is equal to 0, right? So these are the necessary conditions, right? So now what we have our L, right? So I'll be writing L here so that we can do the this particular thing. The derivative, partial derivatives can be taken up in a good manner. So 4x1 square plus twice x2 square plus x3 square minus 4x1 x2 minus lambda 1 x1 plus x2 plus x3 minus 15 minus lambda 2 twice of x1 minus x2 plus twice of x3 minus 20. So will have to take the partial derivative of this L with respect to x1, x2, x3, lambda 1 and lambda 2. So let's start, right? So therefore dabba L upon dabba x1 can be written as, so it will be 8x1 minus 4x2 minus lambda 1 minus 2 lambda 2, right? It is equal to 0. We'll be putting this equation 1, right? So I'm hoping that you are getting this. It is easy, right? Similarly, the partial derivative of L with respect to x2 can be written as dabba L upon dabba x2 is equal to what? It is equal to 4x2, right, minus 4x1 minus lambda 1 minus lambda 1 plus lambda 2 is equal to 0. Hoping that you have got this, what how this came. Dabba L upon dabba x3 is equal to twice of x3 minus lambda 1 minus 2 lambda 2 is equal to 0. This is equation number 3. Similarly, we'll have to equate, you have to find out dabba L upon dabba lambda 1, which is equal to now, it is equal to minus x1 minus x2 minus x3 plus 15 is equal to 0. So this is your equation number 4. Similarly, we can move ahead. We can find out dabba L upon dabba lambda 2. So dabba L upon dabba lambda 2 is equal to minus 2x1 plus x2 minus 2x3 plus 20 is equal to 0, and this is our equation number 5, right? Now what is important here, no? I think that you have got how we have got the equations 1, 2, 3, 4 and 5. It is very simple, and if there is any doubt, you can ask, because unless and until you practice, there won't be any mistakes or the doubts that you'll be getting. So let's focus on this numerical first, and then we can think of moving ahead, right? So now what we want is, now the next step is to find out the values of x1, x2 and x2. So I'll be writing down this step as well here. So find values of x1, x2, x3, with respect to lambda 1 and lambda 2, right? We have to find out the values of x1, x2, x3 with respect to lambda 1 and lambda 2 here. And when we get the final values of lambda 1 and lambda 2, that values can be used to find out what are the values of x1, x2, and x3, right? So solving or equation, adding equation 1 and 2, right? So here it is 8x1 minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0. I'll be reconstructing this, making it minus 4x1 plus 4x2 minus lambda 1 plus lambda 2 is equal to 0. So this is to be added, right? So minus 4x2 plus 4x2 will get cancelled. Here you will be having 4x1 minus 2 lambda 1 minus lambda 2 is equal to 0, right? I'm hoping that you are getting this, right? Further, I can write this as 4x1 is equal to 2 lambda 1 plus lambda 2. Further, I can write x1 is equal to 2 lambda 1 plus lambda 2 upon 4. So what I have done is I have found out x1 with respect to lambda 1 and lambda 2. Now focus on your equation number 3. Sorry, we have got x1 right here. So can we find out the value of x2 as well? So x1 I have found out, and if I put the value of x1 in equation number 1, I can get the value of x2 in terms of lambda 1 and lambda 2, right? So just to do, let's repeat this. So I'll be writing for you what is equation 2, or I can write putting value of x1 in equation 1. What is our equation 1? Equation 1 is 8x1 minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0. And what is, I will be putting the value of x1. So what is my x1 value? 8 uh, x1 will be what x1 is? Twice of lambda 1 plus lambda 2 upon 4. Here I can write minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0, right? So here I can write 4 lambda 1, right? Here it will be 4 1 the 4, 4 2 the 8. So 4 lambda 1 plus 2 lambda 2 minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0. No? So solving this, what we can get, 4 lambda 1 minus lambda 1 will be your 3 lambda 1, right? 2 lambda 2 minus 2 lambda 2 will get cancelled, and here it will be minus 4x2 is equal to 0. Therefore, x2 can be what? X2 will be 3 lambda 1 upon 4. So what I have done is I have found out the value of x1 and x2 in terms of lambda 1 and lambda 2, right? So now considering equation 3, I will also have to find out the value of lambda 3, right? Considering equation 3, I'll be writing the equation 3. That is 2x3 minus lambda 1 minus 2 lambda 2 is equal to 0. Now this particular equation in itself has x3 and the particularly the variables lambda 1 and lambda 2. So I can directly find out what is the value of x3 in terms of lambda 1 and lambda 2. So it will be lambda 1 plus 2 lambda 2, and therefore I can find x3 is equal to lambda 1 plus 2 lambda 2 divided by 2, right? So I think that you have got this, how we have found out the value of x1, x2, and x3 with respect to lambda 1 and lambda 2, right? So I'll be just writing here the values, reconciling x1 is equal to 2 lambda 1 plus lambda 2 upon 4. x2 is 3 lambda 1 upon 4, and x3 is equal to lambda 1 plus twice lambda 2 upon 2, right? I'm hoping that you have understood how these values came. Now considering equation 3 and 4, considering equation, sorry, 4 and 5. 4 and 5. So what are equation 4 and 5? I will be just writing it for you. Minus x1 minus x2 minus x3 plus 15 is equal to 0. This is your equation number 4. And your equation number 5 is minus 2x1 plus x2 minus 2x3 plus 20 is equal to 0. So this is your equation number 5. Now here you can see, no, here what I can do is I can put the values of, now I know what are the values of x1, x2 and x3. So what I'll be doing, I'll be substituting the values of x1, x2, x3 both in equation 4 and 5, and I can find, I'll be getting two equations in terms of lambda 1 and lambda 2, right? So there are two equations and two unknowns, so I can particularly solve this. So let me put this, equation. So putting, just a second. Putting values of x1 comma x2 comma x3 in equation number 4 was, right? So equation number 4 was minus x1 minus x2 minus x3 plus 15 is equal to 0. So what is the value of x1? The value of x1, value of x1 is minus, no, it will be 2 lambda 1 plus lambda 2 upon 4 minus x2. Minus x2 is, okay, what is the value of x2? The value of x2 is 3 lambda 1 upon 4 minus x3, that is lambda 1 plus 2 lambda 2 upon 2 plus 15 is equal to 0. What I can do is I can, multiply it, entire equation by 4, multiplying above equation by 4. What I'll be getting, minus 8 lambda 1. Okay, no, 4 will get cancelled here, right? So it will be minus 2 lambda 1 minus lambda 2 minus 3 lambda 1. Here it will be minus 2 lambda 1 minus 4 lambda 2 plus 15 for the 60 is equal to 0, is equal to 0, right? So solving this equation properly, right? So minus 2, so minus 2 lambda 1, I can write it, for example, 2 lambda 1 plus lambda 2 plus 3 lambda 1 plus 2 lambda 1 plus 4 lambda 2 is equal to 60, right? So now it will be easy. So 2 lambda 1 plus 3 lambda 1 is 5 lambda 1 plus 2 lambda 1 is 7 lambda 1 plus lambda 2 plus 4 lambda 2 is 5 lambda 2, right? So 5 lambda 2 is equal to 60. So this is our first equation in terms of lambda 1 and lambda 2, and it is termed as equation A. Putting, next step, putting values of x1 comma x2 comma x3 in equation 5, right? So equation 5, what we had was minus 2 x1 plus x2 minus 2x3 plus 20 is equal to 0. तो ये हम लोगों का इक्वेशन नंबर 5 था. तो इसमें अगर हम लोगों ने पुट किया माइनस 2 इंटू 2 लैम्डा 1 प्लस लैम्डा 2 अपॉन 4 प्लस x2 क्या है 3 लैम्डा 1 अपॉन 4 माइनस 2 इंटू lambda 1 plus 2 lambda 2 upon 2 plus 20 is equal to 0, right? So what we can do is we can, particularly again multiply the same equation by 4, and what we can get is minus 4 lambda 1 minus 2 lambda 2 plus 3 lambda 1. तो 4 से मल्टीप्लाई किया है तो यहाँ पे 2 रहेगा. So here it will be minus 4 lambda 1 minus 8 lambda 2, and 4 से multiply 24 the 80, so plus 80 is equal to 0. So what we can write here is, you know, uh, 4 lambda 1 minus 2 lambda 2 plus 3 lambda 1 minus 4 lambda 1 plus 3 lambda 1 plus 4 lambda 1 plus 8 lambda 2 is equal to 80, right? So what will be getting, a 4 lambda 1 minus 3 lambda 1 is lambda 1, lambda 1 plus 4 lambda 1 is equal to 5 lambda 1, right? So minus 2 lambda 2 will be minus, it will be plus here, okay. So plus 2 lambda 2 plus 8 lambda 2 is 10 lambda 2 is equal to 80. So this is our second equation with respect to lambda 1 and lambda 2. So solving A and B, so you have two equations and two unknowns. So if you solve this, so you'll be getting lambda 1 value as, lambda 1 value is coming out to be, just a second, 4.44, and lambda 2 value comes out to be 5.77, right? So these are two very important values. Now that we have got, the values of lambda 1 and lambda 2, can we find out the values of x1, x2 and x3? Yeah, so we can find out the values of x1, x2 and x3. We already know what is the values of x1, right? So what is x1? X1 is x1 is equal to 2 lambda 1 plus lambda 2 upon 4. X2 is equal to 3 lambda 1 upon 4, and x3 is equal to lambda 1 plus 2 lambda 2 upon 2, right? So if you will be solving this equation, so that is, uh, what you will be getting is the values as 3.6625, be getting this value as 3.33, this value comes out to be 7.99, right? So what we have got now, this particular x1, x2 and x3 is the point where you will be getting an optimum value, right? So this particularly is x star. X star can be represented as now 3.6625, 3.33, and we'll be getting 7.99 is the point of getting the optimized value, right? You can even find out what is the optimized value, that is f of x star, that you can directly find out, right? So here f of x star is equal to, what is your objective function. It is 4x1 square plus 2x2 square plus x3 square minus 4x1 x2, right? So you can find out this f of x star, no, the f of x star, if you found out, it is 91.12, right? But now this 91.12 is z minimum or it is z max, that we have going to find out. We don't know what this 91.12 is, whether it is z minimum or whether it is z max. We don't know because we have been given optimize that particular.